Hello everyone, hope you guys doing good. In this video, we are going to cover ISCS life cycle phases. There are three phases in ISCS life cycle, that is assessment phase, design, development, implementation phase, and maintenance phase. These three phases makes the core again for your ISCS life cycle, and all the aspects of 62443 revolves around these phases. So it's very important to understand what are the topics or activities are covered in these three phases. There are roles also relevant when it comes to the respective phase. And some of the important concepts are set in the respective phase, like we set security level target in assessment phase. So let's begin with assessment phase. Assessment phase is all about establishing the current cybersecurity posture of an ISCS under consideration. So when I say ISCS under consideration, that is the first step we start our assessment with. So we have to set our scope. How to set up our scope is explained in an elaborated manner in our IC33 course, that is ISA 62443 certification courses. The second course, that is IC33, talks about assessment only. It's a 3 days course. So we deep dive into each of these concepts in assessment phase. 62443 3-2 and 3-3 are referred in this course. So pretty powerful course in terms of practicality as well as in terms of theoretical knowledge on this one. There we discuss about how to conduct risk assessment step by step with practical example, that is our fictitious paint factory of ISA Europe. However, in these videos, objective is not to take you to that level of depth, because those are paid courses. I cannot cover the topics which are mentioned in those courses. However, what is mentioned in what is required as a basic understanding for any cybersecurity professional who is working in OT environment, that's what I intend to explain in this series of videos. This is the basic required knowledge if you are working in OT cybersecurity environment. So you cannot avoid 62443 if you are touching OT environment for cybersecurity. So the very first phase, that is assessment phase, is concerned with the roles, that is asset owner and system integrator. So these two entities are best buddies. They start with the assessment phase and they conclude their contract typically with the design and implementation phase. Typically. Or it's also possible that assessment is done by somebody and design and implementation, some other entity might complete that. When we say assessment phase, the very important start point is establishing your scope. How to establish scope? Depending on the criticality of the system under consideration, site or factory under consideration. So based on the criticality, we establish scope. And here, mutual discussion is very important. That is asset owner and system integrator. Many times, in my experience, even asset owners were not having clear idea about what should be included and what should not. Typically in greenfields, we include complete site. In brownfields, may be part of the site or a particular system under consideration. So once we establish system under consideration or scope, that's where we start with high level risk assessment. What is high level risk assessment? It's a questionnaire based activity. It is not something which we go with our tools and we start digging deep into the networks to find out some vulnerabilities or some misconfigurations. Not at this moment. So the high level risk assessment is all about establishing your context and domain specific knowledge, or fine tuning your knowledge about that specific factory or site. You might be having domain specific knowledge, but that specific site or factory you are working in, we need to understand how things are or how processes are interlinked. Who are in charge of what process? And which are the critical process in terms of the manufacturing or process under consideration. So once we perform high level risk assessment, then we can conclude couple of activities out of high level risk assessment. One of the activities is performing zoning and conduiting. Zones and conduits I will cover in subsequent videos. Now, once we have zones and conduits, basically what is that? It's a group of, we are trying to group the industrial automation systems or components based on their common security requirements. That is your zone. And conduits, we are trying to group communication channels based on their common security requirements. How to perform that, I will cover in subsequent video as I explain. This is one of the activity. The other activity which I can immediately think of is a trigger for policy drafting. The moment we perform high level risk assessment, we also come to know that where are the important gaps or where are the low hanging fruits in terms of policies, procedures, training people, or staffing the correct number of people. So all those things we take care as an output of the high level risk assessment. So the first activity which I mentioned, zoning and conduit, and that's where we start our detailed risk assessment depending on or starting with critical zones. Depending on the criticality, we start with a very critical zone and we start performing detailed risk assessment. So what do we do in detailed risk assessment? That's where we bring in all the arsenal or all the toolings into the site. Now when we said building the tooling into the site, here the approach for greenfield and brownfield is entirely different. We don't intend to find 0 day on a legacy PLC here. That is not the intention here. In brownfield, what we try to find is low hanging fruits and highly exposed systems, mostly by passive means. We don't intend to scan with a Hail Mary kind of configuration. We might trip or we might kill a device. So that is the output of your detailed risk assessment. So we find technical details, in-depth details in detailed risk assessment. With that, we are having enough mathematical data to set our security level target. And also we recommend that what are the identified risks as well as what are the recommendations to mitigate those risks. These are again high level risk mitigations. These are not a very specific mitigation to select a particular firewall, like example FortiGate 100F. Now that is a part of the design implementation. So the output of this phase is your cyber security requirement specification. That's a list of recommendations basically. So the next phase is design, develop and implementation phase. This phase is mainly concerned with asset owner, system integrator and OEM. OEM is a product supplier. And important activity here is interpretation of CRS, cybersecurity requirement specification. So we need an expertise here who has done enough design implementation in that specific domain. So domain knowledge is very important. Domain knowledge means protocol knowledge, the device stack, the technology stack, all those things. Designing various architectures and models specific to that domain is also an important knowledge. Once we have those designs, we send it for asset owner's approval, and with asset owner's approvals, we can go ahead to select the components and systems. Once we have these components and systems, typically we offer this all these components and systems through FAT, that is factory acceptance testing, to asset owner. Where does it happen? Typically FAT happens in OEM's factory or system integrator factory. Once the factory is approved, then we ship these equipment to the site, and that's where your implementation phase in design, development, implementation that starts. So once we start implementation or installation of it, we have to fine tune this for optimal performance and then offer this for third party assessment. Typically that is a process. That's where we also have the CSAT, that is we establish that yes, we have achieved what we have targeted, that is what your security level achieved is now equal to your security level target, and we hand over the systems. With handing over of the system, immediately your maintenance phase will start. And in maintenance phase, typically asset owner, system maintainer and OEM takes part in these phases. It's the longest phase, and in this phase we concentrate more on people and process. Right. In the design, development, implementation phase, although we have achieved the security level target, but mostly it is to with respect to technical stack or technical implementation. Can we also achieve the similar kind of maturity in terms of people and policies? May not be. It's a short duration. There might be a situation of understaffing. There might be a situation of policy paralysis. There might be a situation of no cybersecurity training ever happened in that organization. That requires phased-wise approach, and that will take time. So that's why some of the components or some of the maturity levels have to be achieved in maintenance phase. That's what in ICS Bit Labs, when we are handing over this operation and maintenance manual in your design, development, implementation phase, we clearly bring out these gaps. In terms of technicality, we have achieved the maturity level or optimal maturity for that state, for that current status. But that doesn't mean that it cannot be improved. It requires also the enablement of people and process for optimal performance of technical stack. So that's what we take care in maintenance phase. And in maintenance phase, we design again and develop the organization chart of cybersecurity or risk management and governance. That's the main task in maintenance phase. The technology is already there from the previous phase, that is your design and development phase. And here the concentration again is on people and process. The overall objective of maintenance phase is to improve the CSMS maturity model. So here we try to improve the overall cybersecurity program for OT environment, that is your ISCS. So these are the important 3 phases. As I mentioned, all the concepts and all the activities in 62443 are revolving around these 3 phases. That's all for this video. Thank you so much. We'll cover a couple of more concepts concerning with these 3 phases in subsequent videos. Thank you so much.